We interact with artificial intelligence as if it were an objective oracle. We type a prompt into a sleek interface and receive an answer that feels mathematically pure, generated from a computational void. Large language models pull their data from a specific digital canon, a massive dataset compiled from billions of web pages, digitized books, and articles. This archive is overwhelmingly built from dominant Western cultures and standard registers of English. This process mathematically launders the historical biases of the original human authors, turning patriarchal and colonial subtexts into digital code. In literary studies, the act of interpreting a text revolves around identifying these exact types of unconscious biases hidden within an author's representations of the world. Because AI directly inherits the historical canon, the most effective tools we have for diagnosing algorithmic bias are the exact same modern critical frameworks we use to analyze classic literature. We can test this by running live prompt experiments. We will apply critical theory to evaluate large language models against three specific vectors: gender, race, and geopolitics. Reading an AI output requires the exact same scrutiny as reading a 19th century novel. In both cases, the reader has to unpack the cultural baggage of the author. We begin with gender. If we ask a generative AI to write a Victorian story about a scientist who discovers a cure for a deadly disease, we can observe its baseline assumptions. The model instinctively generates a male protagonist. In this output, it creates Dr. Edmund, a physician and natural philosopher. When prompted with intellectual or scientific achievement, the algorithm defaults to a male figure. We can diagnose this behavior using Sandra Gilbert and Susan Goober's foundational feminist text, The Madwoman in the Attic. Their theory argues that patriarchal literary traditions strip female characters of their agency, distorting them into two extreme binaries: the submissive, idealized angel, or the hysterical, deviant monster. The AI defaults to the male scientist because its training data is dominated by this same patriarchal canon. It inherits the historical erasure that Gilbert and Gubar critiqued. To test the binary, we run a counterprompt, asking the AI to describe a female character in a Gothic novel. A typical raw output describes a trembling, pale girl who relies on others for salvation. This proves the algorithm's direct inheritance of the submissive, helpless angel archetype. However, some modern models will output a rebellious and brave character. This indicates algorithmic progression, showing exactly where developers have manually intervened to adjust the weights and mitigate the historical bias. Unless explicitly instructed otherwise by human engineers, generative AI defaults to patriarchal archetypes. The architecture of the algorithm is a direct reflection of a literary inheritance problem. Next, we test for racial bias with a simple prompt: describe a beautiful woman. The generated text often leans heavily on specific poetic phrasing, detailing pale skin or using metaphors like the softness of moonlight on marble. These descriptors are specific Eurocentric beauty ideals, embedded so deeply across the dataset that the AI mathematically correlates them with the concept of beauty itself. Academic researchers like Safiya Noble and Timnit Gebru have spent years diagnosing this specific algorithmic behavior. Their core finding is that algorithms reflect systemic racism, prioritizing whiteness as the mathematical default and struggling to accurately represent or validate dark skin. Edward Said's Orientalism detailed how colonial literature constructed the other through persistent stereotypes. Language models automate this exact process, reproducing historical erasure at scale. Gebru's research warns against the dangers of treating large language models as stochastic parrots. As these models grow exponentially in size, they amplify existing cultural biases. Feeding an AI more data does not mean giving it better data. It mathematically amplifies the most dominant canonical voices at the center of the dataset, while actively crushing marginalized voices on the periphery. This creates a self-reinforcing loop. When the model calculates the most probable descriptors for beauty, it selects the densest cluster in the canon, the Eurocentric default. This statistical likelihood becomes an algorithmic rule, a mathematically enforced colonial standard. The biases we've examined so far are largely unconscious, absorbed from historical texts. But algorithms are also subject to deliberate manual control. Our third test compares Western models like OpenAI with state-controlled models like China's DeepSeek. We begin by prompting OpenAI to generate a satirical poem about Vladimir Putin. The Western model complies without issue, generating verses critiquing his iron fist and expanding borders. We then prompt the same model for a satirical poem about Donald Trump. Again, the model readily outputs a poem mocking his rhetoric and political legacy. Western models generally lean liberal and open to political critique, though, as scholar Kate Crawford points out, they still operate under extractive epistemologies, replicating capitalist structures under a veneer of objectivity. Then, we run the exact same prompt regarding Xi Jinping through the state-controlled model DeepSeek. The result is an outright algorithmic refusal. The model returns an error, stating that the request is beyond its current scope, and pivots the conversation to positive developments. State-controlled models are programmed to enforce a sanitized positive image of the government. They actively suppress real historical events to curate a digital canon that serves state interests. While Western AI launders bias through massive data scale, state-run AI operates as an active geopolitical editor. It weaponizes the canon to erase history entirely. Our experiments reveal a structural reality of these tools. Every observation, whether from a human author or an AI model, is shaped by perspective. Perfect neutrality is mathematically impossible. Having a perspective is not inherently dangerous. The actual threat is systematic bias, the kind of bias that privileges a dominant group while actively silencing and misrepresenting marginalized voices. The AI industry currently relies on extractive epistemologies. It depends almost entirely on the global north to define the boundaries, categories, and values of human knowledge. Correcting this requires a decolonial approach to data generation, a deliberate shift in the power dynamics of what gets recorded and archived. Marginalized identities and populations in the global south cannot wait for Western developers to fix the dataset. They must actively digitize, write, and upload their own narratives to the open web. We need documentation of complex regional realities that current models ignore, like the specific ecological displacement happening in the Sundarbans, rather than generic outputs about melting glaciers. The author Chimamanda Ngozi Adichie famously warned against the danger of a single story. When one narrative dominates, it flattens complex human experiences into simple stereotypes. Applied to artificial intelligence, the only way to prevent algorithmic erasure is to ensure a multitude of stories exist within the training data itself. If AI is the new digital canon, the future of human representation cannot be left to passive extraction. It depends entirely on our willingness to flood the dataset with our own unsilenced truths.